In the last lecture, we learned about atoms, and that atoms are the smallest and simplest piece of an element. And atoms differ from each other according to how many protons they have. So atoms of a given element, so one element might have 8 protons while another one will have 10 protons. So the number of protons really indicates what element these atoms belong to. So, carbon has 6 protons. And if you look on the periodic table, on my periodic table, look at carbon. Notice the number 6. So that number on the periodic table tells you how many protons the element contains. So what number is listed next to carbon on the periodic table? 6. And that's the number in blue, so 6 blue. Carbon also has 6 electrons. So these are, on the periodic table, we have neutral elements. So the number of protons equals the number of electrons. So, the atomic number is the number of protons in an element. It can also be the number of electrons if this is a neutral element. On your periodic table, this is the number in blue. Now, the mass number is the part of the atom that contributes to the mass. And if you remember when we learned about the subatomic particles, we learned about the proton, the neutron, and the electrons. Now, the 2 subatomic particles that had mass far greater than the other were the protons and the neutrons, while the electrons had a very negligible mass that we don't even count that. So the mass number is the 2 subatomic particles that contribute to the mass. So this is the sum of the protons and neutrons. Now, if you look on your periodic table, there's this number here written in red. And a lot of students think that's the mass number. That's not the mass number, that's the atomic weight, which I'll go over coming up. So the mass number is not that little number in red on the periodic table. It is the sum of protons and neutrons. So we know that carbon has 6 protons. How many neutrons does it have? Well, we don't know. I would have to tell you the mass number for carbon. And a lot of times this is given carbon-12. That's the mass number. So if it has a mass number of 12, it has 6 protons, then it must have 6 neutrons. So there are 6 neutrons present in carbon. So on the periodic table, that number listed in red, you might be tempted to use that as your mass number, but that's not the mass number. That is the atomic weight. So the mass number for carbon would have to be given to you, or you'd have to be given the number of protons, the number of neutrons, so that you could add it together. All right, so moving on, we're going to work some problems where this will be easier to work. So fluorine has an atomic number of 9 and a mass number of 19. So I've given you the mass number. I've also given you the atomic number. We can double check this on our periodic table. Fluorine does have an atomic number of 9. We wouldn't know the mass number unless it was given, which I did give it to you. So the question asks, how many protons, electrons, and neutrons are present? Well, the atomic number tells us the number of protons. It also gives us the number of electrons. Now, so we have 9 protons, 9 electrons. How would we figure out the number of neutrons? Number of neutrons does not look like neutrons. I have to rewrite that. Number of neutrons is equal to the mass number minus the atomic number. So 19 minus 9 gives you 10 neutrons. So I have this table. It looks intimidating. It's really not that bad. There's enough information given in this table so that all you have to do is look on the periodic table for either the identity of the element or the atomic number of the element. You will never, ever, 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 never, ever, 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 never, ever, 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 you getting this? Don't ever use the number listed in red on your periodic table for these tables. So don't use that number in red. That's the atomic weight, and we don't want that. That's not the mass number. So if you ever find yourself filling this column in with 36.2348, it's not right. It should be a whole number. Okay, so back to this table. So this first entry right here, I'm going to work on this one with you. If you look on your periodic table, we're trying to figure out the identity of this element. We can figure out the identity of the element because the atomic number is given. So you're going to look for the blue 26. You find that, and it's iron. Now, the atomic number also tells you the number of protons and the number of electrons. So I looked up number 26. I found out it was iron. You can also fill in the number of protons and the number of electrons. So now all I have to do is fill in the number of neutrons. And the number of neutrons is the number of the mass number minus the atomic number. So 56 minus 26 gives you 30. So 30 neutrons. So I want you to hit pause and work on filling out the rest of this table. Okay, so this second entry, you're given that it has 17 protons and 18 neutrons. Well, since you know the number of protons, you know the number of electrons, since they're equal in these neutral elements. And the atomic number, we know, would be 17. Look on the periodic table, number 17 corresponds to fluorine. Then I can figure out the mass number by adding the protons plus the neutrons, which gives me 35. So for the next entry, 47 protons, that's also the atomic number, also the number of electrons. 47 on the periodic table corresponds to silver. And then the mass number, I'm just going to add the protons to the neutrons. And I get 47 plus 61 gives me 108. Okay, so I have the number of electrons in this one, so I can figure out the number of protons, also the atomic number. The identity of the element I can determine by looking on the periodic table. Number 13 is aluminum, and then the mass number is 13 plus 14 gives me 27. Okay, so the last entry, I'm given the atomic number, so I can look up the identity. That's phosphorus. Given the mass number, so the atomic number tells me the number of protons and the number of electrons. And I can figure out the number of neutrons by subtracting the mass number, so 31 minus 15 gives me 16. So these tables at first glance seem very intimidating, but if you learn how to fill these in, it can be a great source of points. So it can help you not only on your quizzes, but also your exams and pre-labs. So make sure you master these, because it, like I said, it doesn't take very much time to learn how to do it. But if you don't know how to do it, it's like, how do I do this? So, but never, ever, 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 ever use that little number written in red for these tables. Now, on the next page, we talk about isotopes. So, all atoms of a given element contain the same number of protons. That's what makes it that element. So the atomic number is characteristic. However, the number of neutrons can vary. If the number of neutrons can vary, that means that the mass number can vary. So an isotope, the isotopes have identical atomic numbers, but different mass numbers. So for instance, hydrogen has 3 isotopes. So the number of protons are all the same in these isotopes.